Okay guys, welcome back. Making 10-minute videos to make it easy for you to communicate through it. So now we'll get back here to the word occupancy. So again, if we have one person per vehicle or occupancy of only one, then let me get back here to, if you have only one person per vehicle and your lane, every lane, if you know from your highway design, has a capacity. How many vehicles per time, and time here is hour, how many vehicles per hour this lane can pass. So if we have 2,000 vehicles per lane per hour, then just one person every car, so you have only 2,000 people per lane. And this is the picture here, this very famous picture public transit people like myself like to use. If you just everyone using a car, you can see the congestion. The same number of people, you can fit them in the bus. Or if you use bicycle, see how much space you can use on the road. This versus this versus these. So let's put it in numbers here again. If you're able to use some strategies to improve with carpooling and make people carpool together, so you have two people in the vehicle, then and you still have two vehicles that can pass throughout this lane here, then you're gonna end up by 4,000 people per lane. If you have a bus, and this bus can hold 50 people between standees and sit downs, so because the bus is slower, it stops more in stations and it takes more space, so probably we don't use 2,000, maybe use a little bit less of capacity in a lane. And this is still high, by the way. So if you have 1,000 vehicles per lane, but we have how many people now? It's 50 times 1,000, so it's 50,000 people per lane. So you can see now, with using public transportation, taxis, using carpools, we can increase the efficiency and the capacity of your lane really significantly. So let's just want to go here in chapter 2 in your textbook and just review some of the tables that we use in chapter 2, because you'll be asked to solve some questions in chapter 2, very easy questions. I'm going to solve a question once we meet online, in class. So the first one is that when we want to divide the different transportation modes, we have different ways to divide it. First way is intercity, meaning between cities, for example Charleston, Beckley, New York and Washington, or intracity, which is inside the city. And we move as traffic engineers, we care to move people and goods. So these are the different modes of transportation that are classified either by intercity or intracity, person or goods. So you can read it, and this is one first table in your textbook. I'm going to move to the next one. So the next one here is we're talking here about mileage. How many miles of facilities or supply do we have in the United States? So we start here with highways, and that's the first one here. And then we start with the rail, marine or some channels, some waterways. And then talking about goods again, we have pipelines. And finally, we have airports for different. So these are the mileage. You can see here the mileage of your interstates is not as much compared to other local roads. However, it has 20% of person travel. Now we talk here about some freight movement or goods. You can see here trucks has a huge number of tonnage. Tonnage is 1,000 kilograms of weight of goods. So you can see here between pipelines, usually pipelines here is either gas, natural gas or oil. Sometimes you have different modes. So this is specifically when we put traffic in terms of serving goods. Here we're talking about what we call here passenger miles traveled, and you can see here how people traveled, and you can see the highest number ever is people traveling using their passenger cars, and then comes other types of travel. These are different speed and length of trips using different modes of travel. And then we have here different public transportation and different capacities and speeds and lengths of public transport. We're going to talk about capacities in a second, but this is just the speed of each type of public transportation. So this was personal or private, and back here is the public transportation, like we classified different modes of public and private modes. And then comes the table that we will be using a lot, guys, and I'm going to give you a handout about this table if you want to print out this table from your presentation. It's also in your textbook. We have here the capacity. When I say here the capacity, and this is a number that changes based on different things, but this is usually the rough number that we use from freeways to multi-lane highways to two-lane highways, based on the free flow speed, which is the fastest speed you can get on these roads. Then this is the number that we use here, the vehicle capacity passenger car per lane. And then if you have now, and this is the number, you simply just multiply by this. This is called the occupancy. How many people are usually in this highway in the car. If it's a commuter road, then usually you have only one person, but sometimes you have 2 and 3, so the average between both. I'm going to teach you in class how to calculate this number. Then average in the road is 1.3 sometimes. If you have better strategies to add people in the cars or carpooling, you might have more, so you can get here more people or person capacity per lane per hour, or per hour per lane. So what you're going to be asked to do is then you know a highway and the free flow speed of this highway, so you know the vehicle capacity. You can calculate the person capacity of this road. This is for two types of road: uninterrupted, meaning you have freeways, there is no interruptions whatsoever, there is no traffic signals, sign, access, gas stations, it's totally free. Or if you have interrupted flows, you can see the numbers go significantly down if you have traffic signals or stop signs. So you have the same here, and here you have something you're going to be studying in this class, something called green to cycle. How much green time in the traffic signal to the whole signal cycle. I'm going to talk about this in detail in this class. So this means that 30% of the time you have green. So the number, which is this guy here, which we call it the saturated capacity, 1900. If you have no signal or the signal is green all the time, then give you 1900 passenger cars per lane per hour. But because we have cycle, we multiply this 1900 by 0.3, so it gives you these capacity. This is how much the traffic signal can pass every single hour. And if you still have your occupancy 1.3, 1.5, you multiply and get the people or person capacity per auto for different types of arterials and different types of signals. Now we're talking here about public transportation. We have different types of public transportation. We have buses, LRT or light rail, commuter rail. When I say commuter rail, it's the rail between cities. You can see this in Washington DC. Rail rapid transit is the subway, and that's another way and that's why they bring New York City. Here you want to know how many trains coming per hour, and how many tracks, and how many cars. And this is usually a rough number that gives you how many passenger capacity it gives per hour. We're going to solve a complete question in class giving you the capacity of an hour over a single line of each of these, which is a very simple and easy. I know it's more like public transportation part, but it's very important for us as traffic. So our modern problems of traffic engineer, and we do this a lot, is congestion. How can we reduce the congestion to handle demand instead of adding capacity? And this is what we're trying to do. Instead of to add capacity by building more lanes or more buses, we're trying